Good morning, everybody, and welcome to this seventh technical webinar of the cycle Tecna Next, Ceramics What's Next. I'm Paola Giacomini, editor of Ceramic World Review and the e-magazine ceramicworldweb.it, and I'm very glad to stay in your company this morning for 1 hour and a half around. Happy to see that our technical webinar, are having a huge success as far as the audience is concerned. When we created this cycle of webinars in last December, together with the Italian exhibition group, organizer of Tecna 2021, to enrich the social platform Tecna Next, the aim was very, very simple. We wanted to create a bridge between suppliers and ceramic producers worldwide, and I think we did it. We all look forward, of course, to be once again present at the in-presence exhibition next September, on 28th of September in Rimini, and to know more about what will happen at Tecna 2021, I would like to welcome Angela Bellavista, who is the product manager of Tecna 2021, connected with us from Rimini. Good morning, Angela. Welcome.
Good morning. Good morning to everybody. Good morning, ladies and gentlemen. I'm Angela Bellavista, brand manager of Tecna, taking place next September in Rimini, Italy, from 28 September to 1st October. The appointment of today's is as a part of series of webinars organized on Tecna Next by Italian Exhibition Group and Acimac in collaboration with the Ceramic World Web, has registered, as you said, a high interest among the industry professionals and enabled us to keep contact with the ceramic community worldwide in this special period. And today we'll focus on a highly topical issue, energy saving in ceramics. We will listen to the leading companies explaining to us what are the most important technologies for to reduce the energy consumption of production processes in the ceramic industry, and what is available on the market, but what can we expect for the future. And these leading companies, which I thank for participating today, is Sacmi, System Ceramics, Solar Turbines, and Gmm Group will explain to us and present specific technologies that that will be later on also displayed at the exhibition in Rimini. I would like to give you some update about the forthcoming exhibition Tecna for all the future participants. As you know, the last edition of Tecna Argilla was in 2018. Tecna Argilla has always been the international hub of technology for the most advanced manufacturing solutions for the ceramics of the future. And so in this last period, Acimac and the Italian Exhibition Group have decided to further develop and innovate the show, that beginning with its name. So from the 2021 edition onwards, the exhibition will be called Tecna, and we'll use the slogan, "How to make it," to underscore the event's role as a global benchmark in the world of surface covering production technologies, and its ability to respond to the changes taking place in terms of aesthetics, production and application. The 2021 edition to be held, as I said, from 28 September to 1st October this year in Rimini has been adapted to the present situation and will consist of an in-person exhibition where machinery will be physically on display, integrated with the digital platform. Tecna 2021 will have a new layout that will make it easier for our visitors to discover the new concept and the redistributed product sectors during the 4 days of the in-person event. Additionally, as I mentioned, the physical exhibition will be integrated with the digital platform. The Tecna Next platform that we used in these months to organize these webinars will be holding online meetings between international players for a period of 10 days. Throughout the 4 days of the physical show, companies will be able to display their plans to buyers from all over the world, who will be attending in person in accordance with the safe business model developed in collaboration with the Italian Trade Agency and the Ministry of Foreign Affairs and International Cooperation. The Tecna team provides exhibition companies and our visitors with support for all aspects of their participation, including a regular update on ministerial rules with special attention to the entry requirements for travel to Italy. We know that every day we received a new update concerning the international mobility and traveling. For this purpose, the official Tecna website will have a dedicated section called the Safe Travel, which provide 24-hour assistance to international professionals attending the event. This dedicated section of the event website will include regularly update information on entry requirements to Italy, such as easing of quarantine, COVID-free flights, and the Green Pass. So we suggest you to visit our website, tecnaexpo.com, and especially to visit the section Safe Travel. So, well, I wish you all a pleasant session with us at this webinar of today, and I give the floor to Paola Giacomini that will introduce our speaker of today's webinar. Thank you very much and goodbye.
Thank you very much, Angela. Thank you, because you are providing useful information. And of course, we all look forward to be present in Rimini in September, on the 28th of September, after 3 years of absence, as you said. I could say that you are organizing an exhibition for everybody, for those who will be able to travel to Italy, and for those who will not, having the possibility to have a both in-presence exhibition with the possibility to display machinery, the new machinery, and the possibility to have digital events, digital streaming, and all the digital activities you are organizing will support also those professionals who will not be able to be present in Rimini. What we will do, of course, also thanks to these webinars, is to accompany our community, our international community, together with your staff, organizing a new cycle of webinars, which will start probably by mid-September and will go on up to the autumn. This will also give the possibility to increase the visibility of the new technologies that will be presented by exhibitors at Tecnargilla. So we are now drawing the new calendar of technical webinars, and we will inform you as soon as possible. Coming to this cycle of webinars, as said, today we are having our 7th webinar. The second one referred to sustainability in the ceramic production factories. The previous one, which we hold on May 6th, was referred to some of the most recent technologies that are capable to reduce the environmental impact of our ceramic processes, while today we focus our attention to those technologies and solutions capable of reducing the consumption of energy, which, as you all know, represent a very high share of the total production cost. In Italy, for example, it is estimated it's about 20% of the production cost. So it is important to go on, continue improving in the field of energy efficiency, because although a lot of work has already been done in the past years, there's still margin to improve and increase this efficiency. Not only for economic benefits, of course, which are also important, but in order to give our contribution to the protection of our environment. So before giving the floor and introducing you to our panelists, who, as Angela said, are leading companies in their respective fields, just a couple of information. You have the possibility to send to write questions to the panelists using the Q&R function of the Zoom platform, and the panelist will either answer just in time during this webinar, during the streaming, or via email privately. As from tomorrow, we will forward your request and your questions to them via email. Well, let's come to our first panelist today. I would like to introduce you to Stefano Orlandi, who is connected with us from Imola. Stefano Orlandi is the Energy and Environment Product Manager at Sacmi. Good morning, Stefano, and welcome.
Good morning, Paola.
Thank you for staying with us this morning and sharing your very interesting presentation with our audience. Stefano Orlandi will introduce us to the topic of the heat recovery from both kilns and cogeneration plants. He will also anticipate some new applications that were developed at Sacmi, among which we could quote the zero fuel dryer. But let's listen directly to Stefano. The floor is yours.
Thank you very much, Paola. Thank you. Hello, everyone. Thank you for the opportunity. So I will quickly proceed to show you the summary of my speech, which I will try to show in general the possible energy efficiency solution, keeping more attention to the new proposal and quickly proceeding to the solution normally already used. This is, of course, for the time reason. In any case, at the end of this presentation, I leave my addresses and make myself available for any clarification. So, in the ceramic plant, the efficiency use of it is now as a common target for the whole company. Currently, the main machine to recover it are kiln and cogeneration. In my intervention, I will introduce you in the heat from kiln, that I will show you the main system of the recovery from the kiln, putting more attention for the new Sacmi recently introduced by Sacmi, which are zero fuel dryer, and the heat exchanger for the kiln smoke. Heat from cogeneration, that I will see you the various cogeneration system and application for the recovery the hot fumes and the recovery heat contained in the cooling water in case of gas engine. Let's take a closer look at what is a simplified kiln energy balance. If we take a typical tile production operation in which the firing occurs at 1220 degrees, the kiln uses about 415 kilocalories per kilogram of fire product by heat by the fuel. Normally is natural gas. This is the input energy. In a modern kiln with the preheating burner combustion air, outgoing energy consists of endothermic energy associated with a product transformation, total machine dispersion, heat in the product exit to the kiln. Heating exit to the fume chimney is about 215 degrees. This is an important quote of energy, is about 105 kilocalorie of kilogram of fire product. In the Sacmi, this chimney is called AF. Heat exit to the slow cooling chimney is about 220 degrees, equivalent to 19 kilocalorie for kilogram of fire product. And finally, the AAC2 chimney is the heat exit to the final cooling chimney is about 80 degrees, but a big amount of energy is 125 kilocalorie for kilogram of fire product. Energy team focus in the heat of the chimney. This amount of heat represents the 75% of the heat introduced by the fuel. Now, let's see the main type of heat recovery from the kiln. First, the recovery to the dryer. Always the separation of action between the two chimneys of the cooling can undergo variation to allow recovery with higher flow rates and higher temperature. Due to its high temperature, the heat from the slow cooling chimney, the AAC1, used in the fast cycle dryers. We are talking about horizontal multi-level dryers. This machine works with the high recirculation, that is, they are making up of module and repeat themselves, where the internal air is recirculating and continuously correct in temperature and humidity by introducing very hot air. In this machine, the heat generator, in case of not recovery heat, places in each module such air from the internal chamber and increase the temperature up to the set point. For this reason, in any from the recovery must be a high temperature and easy sent from the kiln, practically using only on AAC1 chimney. But with the rapid cycle, the dryer still maintains the full consumption for its operation. In case of vertical dryer, on the other hand, it's possible to send the air temperature that allow to use the air coming also from the AAC2 chimney. This is because the heat generation of this dryer taking air from the environment and therefore with an average temperature of 25-30 degrees. The other type of the recovery uses is the recovery to the spray dryers. Sacmi has been developing such solution for several years, providing them with an automatic regulation system to ensure high efficiency. As in the case of vertical dryers, the spray dryer can accept air coming directly from the AAC1 and the AAC2 chimney, of course subject to modification in order to receive the heat recovery. In fact, the spray dryer burning, taking air from the environment and bring it to the working temperature of around 600 degrees. At the end, the air coming from the AAC2 chimney, which as we have seen has significant flow rates, can be used in the condition of work environments. To do this, however, contrary for the first two solutions, where the recovery is sent directly. In this case, we need an heat exchanger supplied by Sacmi and to eliminate all form of contamination in respect of safety. More recently, progress in terms of technology research and machine development has allowed Sacmi to design dryers with less extreme cycle that can utilize the heat from low temperature recovery. We are talking about a multi-level horizontal dryer, which, contrary to what we have explained above, is modified in its construction to work with a lower temperature. This means that the quantities of air required its operation are greater, but the lower temperature. The clear involves a machine more long, but by modification of the recovery, the kiln, we can feed it with the hot air coming directly through all the chimney of the cooling, AAC1 and AAC2. In this way, the important quantity of air coming from the kiln is sufficient to completely feed the dryer, which doesn't need to be energy by fuel. We see the recovery system. We see before, in a traditional recovery system, the hot air coming from slow cooling. This is to keep the air temperature above 200 degrees. In the zero fuel recovery, the system is provided in an extension of suction pipe of the final cooling. It's the red line in horizontal that extend the pipe in the final cooling. Furthermore, the rest of final cooling air is made to pass through the slow cooling exchanger tube. The rest of the air passing inside the tube inside the cooling. And this system guarantees an increase of recovery airflow rates at the same time the air temperature in order of 170 degrees, which make the rapid dryer work without use of fuel. The increase in airflow introduces an increase in electricity consumption, of course, due to the ventilation, which, however, we will see in the presentation, can be compensated for the introduction of cogeneration system. So we see the heat from the kiln chimney AF. A big amount of heat is contained in the kiln fumes. However, these fumes are contain corrosive substance and make directly use in the heat recovery system very dangerous. A new range of Sacmi filtered tube-tight heat exchanger has now been developed. These are designed to make construction, transport, and assembly as efficiently as possible. This puts us in a position to offer a product that has been engineered to contain cost and ensure a fast return of investment. They are built in a modular unit that are repeated, optimized for working temperature of the ceramic kiln, and built with optimization size for flow rates of the fumes coming from the kilns. These heat exchangers are also equipped with an additional air passage system that opens automatically, which prevents the formation of dangerous acid condensation. To complete the exchanger, there is an automatic clean system which introduction of injection of substance preserve the metallic surface over the time. The air leaving to the exchanger will be free of aggressive substance and will have a temperature of 170 degrees. This recovery can be used in the factory by supply heat, for example, in the finest dryer placed in the entrance of the kiln, named in the Sacmi EUP, or for example, in the spray dryers or in other machines. So we pass to the cogeneration. The cogeneration means the simultaneous production of mechanical energy and heat. The chemical energy contained in the fuel is transformed by a generator in mechanical energy and heat. The ceramic industry requires important quantity of electricity, and therefore it seems the use of this technology with great interest. Simultaneous production of electricity and heat can reduce primary energy consumption by over 30%, compared to the separate production. Since the output is largely used for self-consumption, the transmission and distribution losses was minimized, respect than occur when the electricity passes to the standard distribution. A second important advancement concerns environment protection. Higher process efficiency results a few carbon dioxide and gas emissions, consequently lowering environment impact. There's an economic advantage in form of substantial savings from reduced use of fuel. In addition to such savings, company may be used to take advantage from incentive scheme where is available. So let's see a different characteristic of this generator. We start with the gas turbine. Excuse me. Gas turbine. This is the first machine introduced in the ceramic industry. Is for the power electric production more than 1 megawatt. The second introduced was the gas engine for in the industry production. Industry ceramic is from 1 to 6 megawatt electric. At the end, the microturbine with a little production of electrical energy from 30 to 300 kilowatt. You can see the different characteristics of each generator. This is contained in the documentation that I leave you. But practically, we can see that in the turbine, we have a very interesting temperature of the smoke, more than 500 degrees, have a low maintenance cost, and they have a low emission of carbon monoxide, and nitrogen oxide. In the other end, the gas engine have an interesting electric efficiency, is 10% more than the turbine. At the same time, the part of it is separated in homogeneous part in fumes, which a temperature above of 400 degrees, and in hot water coming from the cooling of the motor. At the end, we have the microturbine, but in the ceramic industry is very little application. Turbines, which are of aeronautic derivation, have the advantage of great reliability, as they have a fewer movement parts. The high temperature of the exhaust gas, approximately 500 degrees, are easily used in the ceramic industry in the combination with the spray dryer. The spray dryer must be modified with the kit containing the heat generation called in Sacmi flue-fired and the peak pipe mixer designed for use with turbines. This solution, even today, is one of the simplest and most reliable from the plant engineering point of view. In the picture, you can see a modern cogeneration situated in the Sassuolo district. This is a large-scale system consisting of a turbine with electrical output is 4.5 megawatt. The gas engine, internal combustion engine, are generally of marine and transport derivation, characterized by high displacement and low rotation speed. They have an advantage of great flexibility, and they can guarantee the high operation efficiency level until 50% of useful. They also offer an high electrical efficiency, 10% more than the turbines. The thermal efficiency instead is about 46% to 50%, is homogeneously derived from the heat containing exhaust fumes and the heat containing engine cooling water, which is a lower temperature. The use of gas engine is increasingly important. This is mainly due to a high electrical efficiency. Again, the great number of applications involve the spray dryer. And here too must be modified with a kit consistent and particular heat generator and pipe mixer. So we see the less possible technology introduced in the ceramic industry that involve the recovery of heat from the engine cooling water and in general from the thermal waste, that is exceed thermal energy generated at low temperature. First one, by an exchanger, is possible to supply hot air for the combustion line to the spray dryer, heat generator, or to feed vertical dryer. It's possible to heat the water for the mill by exchanger. It is possible to bring the water to the temperature of 65 degrees without having problem with the mill's covering. The delta temperature difference and the big quantity of water used have an economic advantage. But another big plus is that the hot water allows to an easier dissolve of the clay and less use of the flocculant. The slab obtained has a 1% lower water content, which has a favorite energy impact for the subsequent processing. With the use of a special heat exchanger, it's possible to heat also the slab up to the temperature of 75 degrees. In addition to economic advantage due to the temperature difference, an advantage is also obtained in the filtering and in the transport of the slab due to variation of its viscosity. The slab has a permanent circulation and turbulent movement to avoid block. At the same time, the exchanger is built with an important thickness to avoid erosion for the abrasive fluid. So we have seen for the watt cogeneration, we can apply in the ceramic industry. So we can see that we can recover fumes to the spray dryer or other thermic machine. We can hot water for mill. We can sleep heating. We have the possibility by hot water to depuration the water industry. I have not talking about of this detail for the recent time, but for who want to know, please contact me. Basically, it's a specially pressurized plate heat exchanger with hot water coming from example for a gas engine can purify industrial water. And the final with the building heating. By the three generation is the future step to optimize all thermal waste. This is possible thanks to a absorption unit machine that use heat to produce water that can range from cold to freezing. The absorption unit can use heat source such as waste heat from the engine, a turbine, or another power generation. It's a chemical physical operation principle. It's based on the evaporation of a particular solution in vacuum condition, where the evaporation have a lower temperature. It's a very simple and reliable machine where basically in the function some pumps. So we can have an application for the cooling press oil, for cooling tiles before the digital decoration, and also in this case for building condition. Today, the 3 and the cogeneration machine have an efficiency level around 90% or more, low environment impact, a low noise level. And thank you to the electronics, great use of friendly. So I think we finish my time. I hope to give you some important information, and I keep myself available for any clarification.
Thank you very much, Stefano, for your exhaustive and detailed presentation. By the way, I remind our participants that if you are interested to watch again or suggest your colleagues to watch this webinar and also the previous ones from December to 5th of May, you can have the possibility to watch the webinars on our websites in the video page of ceramicworldweb.it. This same webinar is being recorded because at 4:00 p.m. today we will have a repeat for our American participants. So you will have the possibility to watch it again. Also, you will have the possibility to download these presentations, the slides, and keep it in your PC if you need it. Well, thank you again, Stefano, and looking to meet you physically at the first possible occasion, and then at Rimini at Tecna in September. Thank you again. With our next panelist, we move to the forming and pressing line. I would like to welcome Eustachio Tarasco from System Ceramics, who will describe some of the advantages of the Superfast technology related to the aspects of energy efficiency. So it is possible to reach advantages in terms of reduction of energy consumption, also optimizing the forming process. Good morning, Eustachio, and welcome. Thank you for joining us this morning.
Good morning to everybody.
Well, the floor is yours, and you can start with your presentation.
Okay, thank you. First of all, thanks to Paola, Ceramics World Web, and Tecna Next for giving System Ceramics the opportunity to participate in this event and to be able to deal with a topic such as energy saving, that we are all aware that today it is vital more than ever before to support industrial activity with an increasingly lower impact on the environment. From a reduction in the quantity of CO2 emitted into the atmosphere to controls aimed at mitigation energy consumption, to reuse the raw material waste, we, as producer of technology for industrial automation, work every day on offering solutions aligned with these themes. One example of how all this works in practice is Superfast, our latest technology for ceramic pressing, conceived to ensure high-level performances combined with respect for the environment and considerable benefit in terms of energy saving. To understand how Superfast meets all this, let's start by analyzing what the ceramic tile is. The ceramic tile can be considered composed of surface with visual and tactile characteristics, thickness for guaranteeing resistance to load according to the intended use of with reference to the legal regulation in force for the ceramic product, thickness deriving from a technological limit, and apparent thickness. Let's define what we mean by technical limit. The thickness is increased to increase resistance, to avoid breakages deriving from the stresses applied to the product during the production phases. In the pressing process, the just pressed product has a low tensile strength, and this is proportional to the dimension of the tiles. Let's define what we mean for apparent thickness. Is a stereotype lead to producing without objective reasons substantial thicknesses as a result of impression of robustness, common market practice, common production practice. What is really necessary in the ceramic product, and where can we take actions? Try to define fundamental and not necessary. What adds value to the ceramic product is surely the surface with visual and technical tactile characteristics, and thickness to guarantee resistance to load deriving from intended use. What does not add value to the ceramic product? Thickness deriving from technical limits. Apparent thicknesses. Why is it important to take action on the not necessary? Because every millimeter of thickness is a raw material that we have to process it. And has to be processed starting from the beginning of the ceramic process, starting from the extraction to the transport of raw material, transformation, pressing, drying, firing, stocking, and transport until the final installation. Be aware that every movement, every thermal change implies energy consumption. And this consumption increases as the masses in movement increase. Overcoming the limits. System Ceramics has eliminated every technical limit, conceiving and perfecting over the last 20 years its advanced forming technology, called Superfast. Superfast produces medium, large, and very large size tile with the thicknesses ranging from 3 to 30 millimeters using a robust, efficient, and flexible production process. Now we have a video showing the entire process of Superfast. The Superfast system consists of 4 main functions: loading, pressing, green cutting, and waste recovery. The value of specific electric consumption of 0.1 kilowatt-hour per square meter is the lowest among pressing systems that we have now. The loading is carried out directly on the lower belt and introduced directly in the press without further movement that could cause separation inside the powder. The pressing is carried out by means of a rectangular hydraulic cylinder that allows the direct thrust of the oil on every point of the tile. The system is not molded, so the air is free to escape without any obstacle. All these allow to obtain a perfectly uniform compactation. I emphasize this aspect because the benefit of compactation uniformity will be resumed later. So this is the Superfast in different sizes. This is the green cut. Is enough to modify the position of the cutting disc to obtain different dimensions. All the exceeding material is collected in the recovery system. The rejected material is crushed. After that is mixing with fresh powder and reused on the bottom layer of the tile. We can say that each granule of powder that go inside our system, Superfast system, become square meter that we sell. We don't have any scrap. Okay, the blue one is the rejected material. The red is the fresh powder, are mixed. The green one is the material that we use for the bottom layer. So, Superfast is able to allow to eliminate unnecessary from the final product, but also elimination of waste through the production process. And this thanks to the compactation uniformity, the green cut, and the recovery system. We have compactation uniformity thanks to belt loading system, to the absence of molds, and to the use of rectangular shape hydraulic piston. What we can reach with this compactation uniformity? We can reduce the thickness tolerances and reduce the caliber tolerances. Saving due to greater uniformity of thickness. Here we have two pictures just to have an idea what is the difference of thickness that we have in conventional press and with the Superfast. The different color, of course, means different thickness. So what we can obtain reducing the tolerances. Here we have an example. If we produce a 10 millimeter tiles, the standard allowed to produce from with a tolerance of 0.5 millimeter. This means that we can produce tiles having a thickness of 9.5 millimeter up to 10.5 millimeter. If you have a technology that allows to produce with a tolerance range, a very small tolerance range, for example, 0.2 millimeter, this means that in our production, we can produce having a nominal thickness of 9.7. In this way, the minimum size is obtained in matching the standard requirement, 9.5, but the maximum thickness is 9.9. This means that we gain material, we save material. Same thing for the squaring process. Here we have the picture showing the tiles obtained with the conventional press and with Superfast. When the compaction is not uniform, we have a different shrinkage. This means different dimension of the caliber. Higher, more uniform density, lower deformation means lower deformation. That means lower squaring margins. For example, from 4 to 2 millimeter. Means less waste, lower cost. Green cut. Green cut machine makes it possible to give the unfired piece the most appropriate dimension for optimizing all the remaining production processes. Adapted the dimension of the unfired piece to the withdrawal of the atomized material makes it possible to always obtain the same dimension, leaving the kiln. When rectifying, the same quantity of material is always removed, the minimum necessary to compensate the tolerance of the piece of those of the rectification process. One more thing, adapting the dimension of the unfired piece, it is no longer necessary to intervene on the compactation pressure value in order to manage any variation in the withdraw atomized material, implying modifying the dimensions of the fired product. Recovery system. Superfast operates with a zero scrap process in which there is no waste material. The recovery scrap is dry crushed directly on the side of the press and then mixed in and introduced directly into dispenser for relying the atomized material. The pressing process is able to manage bodies with a mix of virgin and recycled powder up to 50%. Processed scrap are fully recovered through the crushing and mixing system and repositioned on the first atomized coating layer. Continuous production with total recovery of the waste. The quality of process combined with the high production capacity makes Superfast the best possible solution for every production context and for every type of product. Here we have an example about the capacity of Superfast. Can reach the 20,000 square meters per day. Here we have other technical feature. We can focus our attention to the dimension tolerances and thickness tolerances. These tolerances we normally use to put this tolerance inside our contract for our supply. This is why we are very confident about the quality of our technology. One more thing about the average specific electricity consumption, 0.1 kilowatt hour per square meter. Now we are going to see a qualitative analysis. This is a qualitative analysis just to give an order of magnitude of what is the saving that we can obtain using Superfast technology. We considered a tile of 1 per 1 meter for flooring application. If we consider a conventional press and producing 10 millimeter tiles, in case we can produce these tiles instead of 10, we can produce in 7 millimeter, reducing the thickness because the technology is able to do this. We can save more or less 7 kilograms per square meter. Same thing about caliber tolerances, the better caliber tolerances, thickness tolerances, and zero scrap working condition allow to gain material. At the end, we can reduce the total material of about 34%. If we put this in a context of a plant with an annual production of 10 million of square meter per year, we can reduce 82,000 tons of dry material, and we can save more or less 45 million of liters of water. If we consider the three main thermal processes of ceramic process, we consider atomized, dryer, kiln, we can save 9 million of normal cubic meter of gas. That means to avoid to release on the atmosphere 18,000 tons of CO2. If we extreme our analysis in a different context, for example, for covering application, and it is the possibility to produce 3 millimeter instead of 7 millimeter, we are able to have a saving of 62% of material. That in a context of a plant of 10 million of square meter per year means to have a saving of more or less 105,000 tons of dry material and 56 million of liters of water. Have a total saving for the three main thermal processes of more or less 12 million of normal cubic meter of gas. That means to avoid to release in the atmosphere 23 million of tons of CO2. It is reasonable to think of the reduction of material of 34% in the first case, or of 62% in the second, as an equivalent reduction in energy consumption in the entire production process, starting from the extraction, transport, transformation, pressing, up to the final installation. Conclusions. Technical limits have been virtually eliminated through technological development. The stereotypes linked to the idea that the greater the thickness of the body of the tiles, the more it is resistant remain. These stereotypes lead to choosing, on the basis of habit, to purchase substantially thickness. Today, the offer can be more aligned with demand. It is essential to promote an approach that focuses on using only what is necessary, in the hope that this will lead to more informed market trends. In system ceramics, we are confident that this will happen. The numerous Superfast machines sold in the last year are a strong signal. Superfast and energy saving. Superfast is raw material saving, water saving, sustainable ceramic production, low energy consumption. Thank you for your attention.
Thank you, Eustachio, for your very detailed and interesting presentation, and congratulations also to System Ceramics staff for their research and development activity. Well, with our next panelist, with our next guest, we come back to cogeneration, or better, to smart cogeneration. I would like to welcome Paolo Masiero, Market Development Manager of Solar Turbines, CHP, Energy Efficiency and Digitalization Division. Welcome, Paolo. Good morning.
Good morning to you, Paola.
Good morning. Well, as said, while your colleague in our previous webinar on May 6th anticipated some of the future developments of low carbon cogeneration using both gas turbines and hydrogen, Mr. Benoit Fécamp, today you are introducing us to a new concept, the smart CHP, the smart cogeneration. You will describe some of the advantages that can be achieved if we digitalized our cogeneration plants. We are all eager to know how. The floor is yours.
Thank you so much, Paola. Thank you. So first of all, thank you to Ceramic World Web and TechnoNext for the opportunity that gave us to make this presentation in this webinar. And thank you also to all the attendees that are connected to the webinar. Today, as Paola anticipated, I will introduce the idea about the opportunities provided by the smart CHP and smart gas turbine in terms of sustainability and cost. Talking about this, I will introduce about how the management of the data, the integration with the smartization, I would say, to the production process with our turbogas is able to generate further more value for industries that are applying this kind of technologies. Also, I will talk about which are the enabled technologies that are able to facilitate this kind of transition. And at the end, I would like also to make a short snapshot about how the current environment is supporting these opportunities despite the current economical pandemic and about the current pandemic and economical conditions. In the last century, CO2 continues to grow despite everything. War, pandemic, crisis, CO2 continue to grow. The world is going on. There is a need of electrification everywhere in the world, and also there is a continuous need of increasing the mobility. Mobility is growing everywhere. So the point is that the effort that are necessary to change this trend of growth of the CO2 has to be really very important. European community develop a plan for the reduction, and this is a very aggressive and challenging plan, where if you want to focus on the target of the 2030, we see that there is a request of a reduction of 40% of greenhouse gas emission reduction compared to the level of the 1990. A reduction, an increasing up to 32% of the renewable power that is injected into the grid. That means more or less double of the renewable power capacity installed. And more or less 32% is requested related to the energy efficiency activities. So the pandemic has shown strengths and weakness of our current electrical infrastructure, and it obliged us to speed up in the development of digital infrastructure, data management and communication in order to allow to our daily activities and job to continue. And this is a really strange, but it was an opportunity because this speeded up the management of the data in a proper way. Micro trends. As you can see from this chart, the main micro trends that I want to underline for our typical application is a probable increase of the fossil fuel cost, an increase of the CO2 cost. Everybody, we are seeing how the CO2 is moving in the ETS market, a decreasing of the electricity production cost, an increasing on the use of hydrogen and low carbon fuels, and also a huge increasing of the digitalization. This is supported by European economical plans, the MMF and the new generation European. And so there will be an injection of close comprehensive 1.9 billion euro in the economy of EU in order to support different measures. And if you want to focalize what is a topic of this presentation and our market in terms of energy saving, this there are 8% that is focus on the digital application, and more or less 20.5% of the 1.89 billion euro of subsidies that is focalized on the green transition. Countries are developing their own plans. For example, Italy is following as well this kind of policies with the PNRR plan, and in Italy there is 22% that is dedicated to the digitalization and 31% that is dedicated to the green revolution. So the key takeaway of this first introduction are that for sure a huge amount of resources will be available to boost the European economies. Italy will boost hydrogen, but also Europe will boost a lot the transition for carbon neutral fuel. And for sure, digitalization for everybody is one of the pillars for the next revolution. Just a short snapshot about solar, who we are. We are part of Caterpillar family since the 1981. We are the world's largest manufacturer of gas turbine from 1 up to 23 megawatt. We have installed plants everywhere in the world. We have 65 locations for sales offices and service location for service activities with spare part and maintenance offices. Currently, we have a population of 16,000 gas turbines that are rotating in oil and gas and power generation application. And more or less, our family is comprehensive of 8,000 employees. Related to the portfolio, we have currently 1,200 gas turbines that are operating in power generation and co-generation, allowing our customer to save approximately more than 30% on their operative cost compared to the situation without the CHP, and having a reduction of the CO2 emissions approximately of 40% compared to the typical emission of their own country. Our main markets are, of course, the power generation in general, but also related to the industrial sector. Our experience is mainly focused and mainly developed, I would say, in pulp and paper, chemical and food processing. But in any case, also we have a huge experience in ceramic applications, since we have connected many customers, and currently more than 90 spray dryers or atomizers are connected to our equipments. These slides are present you just to make an explanation and the parallel between the performance of our turbine in terms of drying, so the capacity or the quantity of exhaust that are available from our turbine. And as Stefano Orlandi said, that has more or less the temperature of 500 degrees C. So you see here the parallel of the quantity of the exhaust that are available with the parallel of the typical consumption into the atomizers in terms of standard condition of operation. Of course, we have sorry, also the possibility to connect one single turbine with multiple spray dryers, allowing different typology of production and different loads of production as well. So how energy is produced and consumed is changing dramatically today, and we are following the changes, develop new products and services. The market currently is asking for sustainability. The electrification, as I anticipated, is growing, but is growing more in Europe and in US, is growing, developing renewables. So renewables are increasing their percentage into the grid, and they are growing very fast. And for this reason, the grid is also asking for stability and the capacity to be very flexible. The answer to the products that we develop and the solution that we develop in solar turbine are related to fuels, as anticipated. So our gas turbine are already ready now for hydrogen and for many carbon neutral fuels. Now we develop, and this is the subject of this presentation, our big data capability. You will see later on how to monetize this data. And by leveraging our huge experience in distributed industrial CHP application. Also, everything is focalized to support the savings for our customer, because cogeneration does not make any sense if it is not able to provide savings for customer. As anticipated in the introduction, now I would just now to jump in showing how we utilize current technologies, some of them already in our portfolio for more than 15 years, to make a better performance, economical performance, and maintain and increasing the environmental target of our customer. Currently, we do not have available information related to a ceramic customer, but we have selected one application, one particular customer. It's a pharmaceutical application that utilize the same size of gas turbine that typically use in ceramic and have the same load profile in terms of electricity and thermal that are typical for many ceramic industries. So you see here in this slide, I reported the electrical consumption, fluctuation of the electrical consumption of this customer from 5 to 7 megawatt electrical power. The heat demand is equivalent to the demand, a flexible demand from 1 ATM 140 up to, in parallel, 4 ATM 110. This is the level of cost of the electricity and the gas, and the current gross margin of this customer, means the saving that this customer is able to obtain using this kind of solution, is approximately 332 euro per hour. So as anticipated, you can see here in the upper chart the profile of the electrical power, and the same in the lower part, the profile of the thermal requirement. So you see that there is a cyclicity, a weekly cyclicity. They stop the major consumption during the weekends, but also during the week, they continue to go up and down, both in thermal and in the electrical, because this is due to multiple batches production. So the enable technology to talk about smart has been developed internally. So this is a patent internal technology of solar in a path that started more or less 15 years ago, and have seen solar in the first step years ago to develop all the knowledge related to the data provided by the turbo machinery itself, our turbo machinery. But little by little, we started to develop integration backwards, looking into the production of our customer. And now we are also looking outside of the boundaries of the facility of the customer. So from the simple application in terms of electrical tracking and thermal tracking of the utilities of our customer, now we move into the maximization of the revenue of the complete CHP embedded into the system of the customer, looking and monitoring the primary energy saving and also where are in place, trying to calculate in real time the efficiency certificates in order to verify the economical benefits and the environmental benefits of our customer. Smart gas turbine means integration, means automatization. And it's important to underline that not most efficient, but most profitable and sustainable is the solution that can really support the industries. We focus on 5 main directions. First one, reducing the operational cost. Second, monitor the plant efficiency, increase the available hour, optimize the financial performance, and at the end, how to play with the external market, playing with the demand response market. The enable technology, as I anticipated, has been developed internally and is based on the acquisition of data, their monitoring data and management up to, and this is very important, formalize a decisional process driven by the artificial intelligence. So the system, having all this big data connected together, the ERP of the production, the weather forecast, everything that is related to the CHP itself, is able to calculate which is the best operational point of the turbine itself and suggest this to the operator. Inside platform is a solution technological based end-to-end technology and has been developed starting from the acquisition of data from the interface of the customer. So you do not have to do anything. We simply connect to your data and we have our system that is able to manage and develop the integration with the other system and functionality. The platform inside has been designed to integrate reliability, integrity, and quality of the data. So let's start now to jump into the 5 direction and to now pragmatize the data, the digital data that stay in the cloud and monetize this data in something that is tangible. So euro at the end of the year. So first of all, let's talk about the reduction, the operational cost. The system that is completely integrated into the ERP of the company is able to reduce the operative cost, is completely automatized, and this allows us to make an unmanned operation, so not necessary to have people looking at the CHP, up to 72 hours. The case that we analyze show that the customer that in the past allocated the cost of 3 people to this kind of operation was able to reduce of 1/2 this cost directly to the CHP. So with a direct saving close to 60,000 euro per year. The second dimension that we analyze is the increased available hours. So reducing the time of stop of the machine for the scheduled maintenance. So doing that, having the possibility to connect all the data of the machine and the production of the customer, we typically have the possibility to reduce from 5 to 10 days per year. So reducing of this amount of days the schedule maintenance. This depends of the age of the turbine itself. For the calculation of today, let's take only 5 days, so the minimum number of saving that we can achieve. So if you remember the 332 euro per hour of saving for the customer, having these 5 days of more operative for the machine means to have more or less 40,000 euro per year of extra benefits. Then we focalize on the real warranty availability of the machine. Means we don't want, or we want to reduce as much as possible the possibility to have unscheduled maintenance. So just to make you an example, if we think to have a scheduled maintenance of 4 days, when we warranty 95% of availability, this means that typically we stop unscheduled 342 hours per year. If we are able to increase this availability up to 97.5%, means that we are reducing the unscheduled maintenance of 123. The difference between 342 and 123 represent more time that you can use the turbine, avoiding to purchase utilities from the grid. And this is a big saving for you. It's a saving of approximately 73,000 euro per year. Fourth step is monitor and optimize the plant efficiency. So from the level of the monitoring with our system, of course, we are able to represent and monitorize all the typical parameters that are represented during with a DCS, a distributed control system. But also we are able to integrate this parameter in more important indicators for the customer, like the efficiency of the CHP, the specific emission of CO2 per kilowatt hour of the electricity that is produced, the cost, the levelize and the cost of the electrical energy that is produced by the CHP compared to the target of the grid, for example, and the quantity of CO2 that is not emitted compared to the situation without the CHP. In the chart, you can see in the upper chart, the system that is suggesting in light gray, I would say white line, a different operating condition of the turbine in terms of production of the electrical power compared to the requirement of the facility, the blue line, and compared to how the turbine in orange is following the load in electrical load tracking of the facility. In this way, we have the possibility to increase the electrical power produced by the turbine, to participate to external market, so the daily market, and later on you will see also the demand response market, increasing the amount of electricity that can be sold to the grid. So we move from a situation in electrical tracking system of selling more or less 1,800 megawatt hour to the grid, to a new situation with the possibility to sell to the grid 5,300 of megawatt to the grid. This helps to reduce the CO2 emissions per megawatt, because we are able to operate the turbine in a better efficient way, and also to reduce the electrical cost, the specific electrical cost produced by the turbine due to the fact that the turbine again is operating in a better point. Last but not least, here I reported the crazy trend of the cost of the CO2. The system is able also to integrate this kind of information, and especially during the weekend is able to decide or to suggest to the operators if it is the case to maintain the turbine in operation or switch off the plant, making the balance of the cost and looking at the opportunities of selling the electrical power to the grid, or if the costs are too much due to the CO2, better to switch off the system. This way of operating the turbine help the customer typically to have an additional margin of from 5 to 6%. Let's take 2% for our calculation. This would be an extra 53,000 euro per year of benefit. But when we talk about smart CHP, we have to think differently. So instead of focusing, as it was in the past, only on the characteristics that are surrounded by yellow, so the energy plan requirement and CHP operation, now Smart CHP also consider sorry, or other typology of data like the production plant, the monitoring of the efficiency, the cost of gas and the volatile cost of the electrical power, the CO2 cost, the opportunities driven by the demand response, the integration with the renewable grids, and of course is considering also the weather forecast, because with low wind or low sun, renewable energy will be not supported the grid, and our smart CHP can support the grid. This support is very important when renewables are growing, because this sorry, is helping to balancing the grid into the demand response game. Renewable are very good because are reducing the carbon, but they are injecting into the grid an uncertainty in terms of availability of the renewable itself. Having a smart grid, a smart turbine system connected with the grid directly, we can support the grid with the frequency and with the power that is required suddenly into the grid itself, in order to stabilize the frequency of the grid and the variation, the sudden variation that we have in the node of the grid. In this example, we supported in our Belgian customer the grid with the R1 and R2 contribute to the demand response generation, and the comprehensive benefit from the total year is close to 36,000 euro. So at the end of the day, collecting all this benefit, a smart CHP monetizing all the data was able to provide to this customer benefit that is more than 260 euro per year of extra benefit on top of the typical benefit that is driven by the use of a CHP. This number is not including higher efficiency cogeneration incentives and CO2 reduction due to this operational mode. So key points, just to conclude. As I said, how energy is produced and consumed is changing today, and we are following this change with our product. Digital and hydrogen capabilities are our answer to this change of paradigm. And what I'm telling you is share your data with us, and and for sure we will make the difference, as you have seen. Now it's up to you. Just imagine what we can do together. Thank you so much.
Thank you, Paolo, for your very, very detailed and interesting information presentation. By the way, I remind our participants that articles taken from these presentations, from these webinars, both the previous one at the beginning of May and this one today, will be published in our special section about sustainability in Next Ceramic World Review that will be published in July, so don't miss it. Well, we have come to our last speech today, which is presented by Aleandro Azzaro, Chief Business Manager of Gmm Group. I introduce you and welcome to, yes, good morning, Aleandro. Good morning, and
good morning, Paola.
Today. Well, with Aleandro, can you hear us?
Yes.
Okay, with Aleandro, we go to another topic. We will try to understand how it is possible to achieve a higher energy efficiency by adopting new solutions and services and innovative services as far as predictive maintenance is concerned, for example, or industrial revamping, for example. So let's listen to the news from Aleandro. The floor is yours.
Yes, thank you, Paola, for your introduction and for the opportunity gave us to present our group. I will share my presentation. Sorry. All right. Can you hear and see it?
Yes, perfect.
All right, that's great. So thank you for your introduction. Actually, today I'm going to talk about the role of Gmm Group as a strategic partner for the energy saving within the industrial process in the ceramic industry. And I will start with a brief introduction of the group from its establishment and its evolution, which got today to a group which proposed itself as global industrial partner for the ceramic industry. So everything started in 1973 with the establishment of GMM Industrial Components, which is actually the company providing supply of industrial components, both for the OEM markets and for the MRO markets, so for the constructors and the end users. And I would say the pillars of Gmm Industrial Components is the knowledge of its internal specialists and the experience built in about 15 years of history and the partnerships with some of the most important players in the field of services and solution supplying. Then, from what was a strong willingness from the property and the direction to offer a wider range of services, added value services for the client, GMM started to diversify not just horizontally with different sectors, but also vertically, entering actually new business units such as the maintenance services one. And that's it when in 2016 there was the acquisition of BBM, which is actually the company that provide specialized in maintenance and above all predictive maintenance services. And we will see more in detail after. Then in 2016, there also was the establishment of our American branch, Gmm USA in Clarksville, Tennessee, which is actually the American Ceramic Valley. And we did this in order to take the challenges and answer to the needs of the American ceramic producer. And finally, we get to 2020, where we acquired Malaguti, which is actually the company providing industrial revamping services. So as we can see and understand, our main objectives, goals, and mission has also evolved during this year. Indeed, today our mission is to sustain companies in the ongoing efficiency improvement process in order to avoid not planned shutdowns. And I would like now to focus in this last part of the mission, so not planned shutdowns, because actually this recalls us to a really common concept in any production facilities. And I'm talking about the OEE, overall equipment efficiency, which is actually one of the most important index in production. And it's actually an index that ranges from 0 to 100, and in percentage, it gives us the information. It gives us the information about the overall efficiency of the equipment. So, if we take a deeper look at this index, we can see that it is composed by three important variables. So, the availability of the machinery of the plant, the performance, and the quality. And I would like now to take a deeper look at the first variable, the first and important variable, the availability, which is actually composed by the theoretic availability of the machinery of the equipment, and the actual availability without all the planned shutdowns. So what we can suddenly understand about this variable is that any and every unplanned and scheduled shutdown can impact in a negative way, like reducing this variable and reducing all the overall efficiency of the machinery. So what we do as a group, as GMM Group, is to develop services and solutions to provide to our client to improve this variable, to improve the availability of their critical machineries in order to, at the end, improve the overall equipment efficiency. And in order to achieve this important goal and this important mission, it has been critical, fundamental to build the knowledge in the field of services. That's why we acquired BBM. And actually, what BBM does is the most important part is. Of course, the specialized maintenance, but above all, the predictive maintenance for critical machinery, which is actually generated with the different steps. We have the data acquisition steps and the analysis interpretation in order to give us a diagnosis and a detailed report of which is the health condition of the critical machineries in order to have the opportunity and the possibility to schedule eventual shutdown and not to receive breakages that will lead to very high costs. And of course, everything is closed with a specialized intervention and maintenance from the expert technician of BBM. And we can also see here the clear synergy with GMM Industrial Components, with the supply of the best quality and reliable components for the maintenance. Of course, has been also really important the acquisition of Malaguti, which actually is the company that provides industrial revamping and improves the performance of the equipments. Indeed, what we do thanks to this company is to recover equipments which would have been otherwise dismissed from the production. So revamp these components and reintroduce these components and equipments in the production and the production system. So we can clearly see the theme of circular economy, and also we can see an environmental and energetic sustainability. Of course, during this process of revamping, we upgrade technologically these equipments, and we release all these equipments revamped just after really strict and rigid testing and certification. So this is the panoramic of our group, and I would like now to focus on the projects that the GMM Group has developed during this year with our most important partners and global player in order to give energy efficiency solution for the ceramic industry. Indeed, as we can see, we developed important projects with some of the most important players such as Festo, Kluber, Prüftechnik, and Gates and SKF. Starting from Festo, which is actually, I would say, the main player, the main global player in the industrial automatization through the pneumatics. We face together the theme of energy efficiency through a sustainable productivity for the industrial automatization. Indeed, what we do, thanks to this partner and thanks to our internal product specialty, is a smart design, both from the project side, so from the OEM side, and from the revamping and the MRO side. So we do a smart design of the automation application, selecting the right elements and the right cutting-edge technologies, which can actually clearly and clearly respond to the production needs, avoiding any cost or energy inefficiency. And above all, one of the most important service that we provide with this partner is the research and remediation services for the air leaks. And even if in any production facilities or plant where there is an intensive use of compressed air, and even if this cannot seem like one of the most urgent or problematic situation in any production facilities, I would like to show some interesting and important digits and number to understand actually which is the real which are the real sunk costs linked to eventual leaks of air. Indeed, what we got here in this table is the sunk cost of eventual leaks, depending on the diameter of the leaks and the service pressure. Indeed, what we the service pressure. If we, just to give an example, when we perform an overall remediation, we can get from 20 to 30 leaks, and on average, the diameter of the leaks is about 1.5 to 1.5 millimeters, and usually on average we have a service pressure ranging from 4 to 6 bar. So we can suddenly understand with an average cost, annual cost of the leakages of about 1,000 euro, if we multiply this cost for 20, 30 leaks that usually you can encounter, we can soon understand which can be the energy and cost efficiency that we can perform with this kind of services. And also it's very important because when we have problems and inefficiency in the air system, what happens is that actually also the performance of our equipments utilizing this air actually decrease, and so we come back to the prior index, the OEE, the over equipment efficiency. So when we got this situation and the performance of the equipments is decreasing, actually most of the time the operators just increase the pressure in order to give again to the equipments the right performance. But then we can understand that actually we are producing even more air. We are producing even more air, and we are increasing the cost, the energetic cost, and sometimes this also leads to the installation of new air compressor to fill this maintenance. And of course, we can understand that this increase the cost and of course the energy efficiency when we actually can resolve everything just doing a remediation system services. I will talk about now Kluber lubrication and the project that we launched with Kluber, which is actually one of the most important leaders in the industrial lubrication. And indeed, what we can do thanks to this partner, and there is an expert technician, is a consulting and analysis with our clients for the lubricants utilized in most critical applications, in order to see if we can perform cost and energy efficiency improvements. So then we base from to the phase of replacement of the lubricants, and we start actually a continuous monitoring to see the improvement in terms of cost and energy efficiency. To give some numbers and digitals, so here we can see some of the most common application in the ceramic industry production processes. And we can see, for example, gearboxes, mixers, mills, and air compressor. So what we can see here, after we applied some of the utilized some of the products of Kluber, we got savings ranging from 3.6 to 5%. And if we take a deeper look to the most important and critical applications such as mixer and MIS, we can see the actual saving in terms of energy. You can see, for example, for the MIS, we got a saving of about 600 megawatt hour. And I think it's even more important if you translate this in economic terms, so we can clearly see which is the cost and, of course, the energy savings that we can perform just with the selection of the right lubricant. I will talk now about gates, which is actually the lead, one of the most important leader in the transmission, in the power transmission. And actually what we do with this pattern, if we think about the traditional application where we got the power transmission with belts, what we can do actually is to calculate the right number of elements of transmission, in this case belts, to apply, in this case replace for the application, giving what is a clear ROI scheme about the energy and cost efficiency that we can achieve, and we can also provide the maintenance services with the expert technician of BBM that can cover all the phases of these solutions. So from the calculation to the replacement to the startup phase of the equipment. I want to give also here an idea of the energy saving that we can achieve just with the replacement of these transmission elements. For example, if we have a 30 kilowatts motors, electrical motors operating at 89% efficiency, 24 hours, 7 days, about 11 months per year, we get an annual energy cost of 26,000 euros. So when after we replace the transmission element, in this case the belts, with, for example, the Gates technology synchronous drive, what we get soon is an improvement of the engine efficiency of about the 5%. And this is translated in an annual energy saving of about 1,300 euros. So now, if we want to contextualize this application in the ceramic production processes, well, it's quite common to see this kind of motors in the ventilation system during the firing processes. So usually the kilns in the ceramic in the firing process gets between 20 to 40 ventilation system, and each get on average a motor of 30 kilowatts. So here again, if we multiply the annual saving of about 1,300 for 20 to 40 motors, we can understand which is the energy efficiency and also the cost efficiency that we can get with just the replacement of this transmission element. I will talk now about proof technique from the group, the American group Fluke, which is actually the most important strategic partner, which give us all the technology and the knowledge to perform our analysis and to track what is the industrial energy consumption. If we think, for example, at the previous services of redemption and research of air leaks, for example, we utilize sophisticated sound waves equipments from Proof Technique. The same we utilize Proof Technique instruments for to measure, to analyze the engine and motor, electrical motors absorptions. And of course, when we talk, all of these equipment and instruments can give us the opportunity to generate data, to analyze this data, and to give us a plan to avoid unplanned shutdowns and breakdown. Actually, we are talking about the real predictive maintenance services. Indeed, thanks to the technology of Proof Technique and the expertise and the knowledge of our technician, we can perform which is the predictive maintenance in order to avoid the unplanned shutdowns, as I said before, by actually producing data with the technology provided, producing data from the critical machinery that we need to continuously monitor. We can produce this data in a manual way or in a fixed way, actually sensorizing all the critical machinery. And actually we are talking to really actual themes such as digitalization and Industry 4.0. So we can see the importance of this partner for the work of our companies, and also for the energy saving projects. I will now conclude with one of the most important partners for Gmm Group, which is SKF. And actually also SKF give us the opportunity to supply energy saving products and solution. And above all, thanks to the solution factory, we are able to perform the engineering and revamping of important application. And we can see here a clear benefit from the side, from the environmental and energy sustainability side. And we can also perform maintenance services and above all performance contracting with this partner, with the clear goal to improve the performance of the production performances of our clients, reducing cost and energy inefficiency. So that is a panoramic of the Gmm Group and all the project and solution studied for our clients in the ceramic industry, with a clear goal and objective to achieve energy savings. I thank you all for your attention, and I give the word to Paola.
Thank you, Aleandro. Very interesting information, useful. Well, we've come to the end of our today webinar. I hope that you had the opportunity to receive useful data and highlights and information for your job and how to improve your energy efficiency. Well, I would like to thank our panelists for their excellent job, and also I would like to thank you for staying with us today for our couple of hours of technical information. Just I remind you that this afternoon at 4 p.m. There will be a repeat of this webinar on ceramicworldweb.it in the video section, and I would like to invite you to join us also at next webinar on 9 June. It will be on a totally different topic, that is the intralogistic 4.0 for the ceramic factory. We will be in the company of, again, leading companies in the fields like Sacmi, System Ceramics, Cytec. And for those of you who are interested in the body production department processes on the 30th of June and 1st of July, we will have our last webinar for this first cycle on new raw materials and body preparation techniques, so don't miss it. Well, there's nothing else to say, but see you all again on June 9 and follow us on ceramicworldweb.it and on our social pages on LinkedIn and Facebook and Twitter. Goodbye. Have a nice day.